Cosine rule then. Again, it applies to triangles that are not right-angled triangles. We use the same convention as we do with the sine rule, and we use it in two forms. Either a squared plus b squared, a squared equals b squared plus c squared minus 2bc cos a. Now, as I said, it looks complicated, but it actually is, especially with the calculators we have nowadays, quite easy to use. You just plug in the numbers and we'll be practicing it. That's set up like this if you want to find a side, and we'll look at an example of that, side A, for example. If I want to find the angle, then I rearrange this formula, and so this formula here has been rearranged to find this one. And if you're interested and you want to practice your rearranging formulae skills, see if you can start with this equation and rearrange it to get this one. It's not that difficult, actually. It looks as though it might be, but it isn't. So that's a good one for you to practice. You're not expected to be able to do it, but you might want to have a go. The bottom line is you need to be able to use both these formulae. So let's look at it by way of example. Another thing to note about these formulas is if I'm after side A, that automatically means I must know the angle opposite it. So if I'm after side A, which is this one, I've got to know that angle, which is opposite, and also the other two angles. So let's look at an example and see how that works through. Right, now let's look at this example, this question here. Can't use the sine rule because I don't know a ratio. If you look at it, I know that side, but I don't know the angle opposite it. I know that side, but I don't know the angle. I know this angle, but I don't know the side opposite. So I can't use the sine rule. Sometimes we say we use the cosine rule, and you'll probably see this written in textbooks. You use the cosine rule if you know two sides and what's called the included angle, which is the angle between the two sides. In that case, you use the cosine rule. But I always think the easiest way is just, if you don't know a ratio, use the cosine rule, which is true in this case. Okay. Now then, what we do is, we've got to use the formula. Well, as I was saying on the previous slide, this side A, it's set up to find a side at the moment, assuming you know the angle opposite it, which we do in this case. So as far as labelling is concerned, that is going to be side A, the angle opposite, sorry, the side opposite the angle we know. And so now the other two sides are B and C. It doesn't matter which one you call B and which one you call C, so that's not important. We just need to know these other two sides and that angle, which we've got, so we can use the cosine rule. So now we just put in the numbers. A squared equals b squared, which is 5.2, say, plus the other side squared, which is 4.5 squared, minus 2 times 5.2 times 4.8 times the cosine of 60 degrees. Notice when we put the numbers in, if we look at this formula here, 2bc cos A, that means if there's no symbol, multiply 2 times b times c times the cosine of A. Once you put the numbers in, then you do put the multiplication symbol in. So 2 times 4.5 times 4.8. And now you get your calculator out, making sure you're in degrees for the angle, and then key it in one hit. 5.2 squared plus 4.5 squared minus that. Answer 22.33 to four significant figures. And now we've got to be careful. Does that tell me A? No. Yes, it tells me A squared. So it's very easy to make this mistake. This doesn't tell me A, it tells me A squared. So finally, A equals the square root of 22.33. So on the calculator, I'd probably just hold that answer and just square it answer, and I get side A equals 4 point something 4.725, 4.73 to 3 significant figures. And if we're talking about accuracy, going back to the original problem, we've got 2 significant figures, so you might call that 4.7 to 2 significant figures. So to quickly recap, in this particular example, we can't use a sine rule because we don't know ratio. We're after a side, and so we call that side A and apply this rule, the cosine rule, and we just put in the numbers. So that's what I meant by there's no rearrangement in this one. You just got to put the numbers in. And making sure that you're in degrees on the calculator, you should get the answer. There's one other example, which is where you're after the angle. So let's look at this one more example. Okay, in this example, we know all 3 sides, but we don't know any of the angles. So I obviously can't use a sine rule because I know none of the angles, so I don't know a ratio. So I have to use the cosine rule, and I use it in the form to find the angle. I can use it to find one of these angles. And the formula, as we've written down before, angle A is this inverse cos, which means the angle whose cosine is b squared plus c squared minus a squared all over 2bc. That's the cosine formula in that form. Now we're after all the angles. So we're just going to try and find one of the angles. And it's up to us which one we find. Unless you're particularly after, if this was in an engineering scenario and you've got this shape, and you're particularly after this angle in this corner, say, because that's the structure or the part of the structure you're interested in, then that's the angle you want, obviously. But otherwise, you just decide for yourself which angle you're after. And that will be the angle you call A to apply this cosine rule. So then, if that's angle A, this must be side A. And as before, after that, it doesn't matter which one of the other 2 you call B and which one you call C. These A's are the only one that are important. So now I can put the numbers in to the formula and work it out. A turns out to be inverse cos of B, which is going to be 6.9 squared plus 4.8 squared minus 5.3 squared all over 2 times 6.9 times 4.8. And again, you can do that in one hit on the calculator using the inverse cos button and the fraction button. So we work that out and we get angle A is 50 degrees. So this is 50 degrees. Now we're after the other angles. So we've got a choice now because we know a ratio. We now know this ratio. I could decide, okay, now I know a ratio, I'm going to go back to the sine rule and use the sine rule to find, say, this angle here by using the ratio rules. Or I could decide, well, I've got the cosine rule, why not carry on? So this time I'd call this angle A, and then for this side would become side A, and I'd put the numbers into the cosine rule just as I did before, and I'd find that angle. Okay? These examples are the only 2 where you're going to come across using the cosine rule, because otherwise, in any other situation, we'll have a ratio. The only times you don't have a ratio is if you've got 2 sides and the included angle, which is the first example you looked at, or we know 3 sides and none of the angles. Okay? Now, have a look at, please, in your textbook, page 226, this exercise here. And try these questions. Don't bother to find the areas. Just solve the triangles. Find the missing sides and angles.